In Chapter 8, we are continuing discussing scatter plots and data, but we are going to be taking it a step further. Now we are actually going to be able to come up with an equation to model the data so that we can make predictions. And so that's what this chapter is all about, is the different pieces that go into finding that model. So let's start with the definition of what a linear model is. It is an equation of a straight line. That's an important key feature. Linear models are required to be straight lines. The points in the scatter plot definitely are not going to all line up, but they should be in a general kind of line pattern where a straight line can be used to summarize all of the data. And the linear model, its purpose is to help us understand how the x and y values are associated. Now, within our videos, within your notes, within your textbook, you're going to see a variety of words that also mean the same thing as linear model. So if you see the word line of best fit, least squares line, or regression line, they all mean linear model. So make sure that you understand exactly what those words are. So let's look at various forms of regression that we've seen. So you should have, at some point in Algebra 1, learned what the equation of a line is. And it should have been y equals mx plus b. I'm sure you've seen that in Algebra 1 and Algebra 2 and even back in middle school. That's the same equation we use in statistics, but our notation is going to be slightly different. So this is the notation that we are going to be using in this class. So I want to point out what some of these things are. So in the past, m has always been our slope, and b has always been our y-intercept. Well, we're going to write it in a reverse order. b sub 0 is now going to be your y-intercept, and b sub 1 is now going to be your slope. And the other very important notation is this y hat notation. Y, and yes, that's how we say it, is y hat. That little, we call it a caret key. The caret symbol above the y is extremely important. What it means is that this is a model that is an estimate. Okay, so this little caret right here, different color there. That little guy there is a caret. We call that y hat, and it means that this is an estimate. It means that it is not an exact answer. It's just an estimation based on our data. So the estimate made from the model is what we call the predicted value. So anytime we make a prediction, we are finding a predicted value, and y hat is the fancy name for our predicted value. So what we're going to look at now is an example that we've actually already seen before. If you remember, this was a problem that we did in Chapter 7. Okay, this was the table that shows the temperature outside and the sales for ice cream. And we needed to create a scatter plot. Now, that was what we did in Chapter 7. So I actually copied over the information from Chapter 7. I copied over how we found what to count by on the x and y axis down here at the bottom. That was what we counted by. And I made my scales exactly the same that we had in Chapter 7, and then I regraphed the dots. And I did this to save a little bit of time, so you can either make a note to reference back to Chapter 7 notes for the graph, or you can pause the video and recopy the graph down. Because our goal today is to take it a step further. We need to calculate two things. We're going to calculate the correlation, and we're also going to calculate the equation of the line of best fit. So if you remember, back in Chapter 7, we actually learned how to calculate correlation using the graphing calculator. And you watched a video and you tried a few on your own. Well, when we watched that video, it also spit out some other numbers. And I told you guys that those other numbers would be important to us later on. but they weren't important to us at the time. The only thing that we wanted from before was the correlation. And so from our previous video, we knew that the correlation, which is always R, was the number 0.958. But again, that was from the last video. Now, our issue is, how do we get the line of best fit? Well, that's the beautiful thing. The screen that gave us the correlation is the same screen that will give us the line of best fit. So when you went in your calculator and you went to Stat, and you went to Edit, and you put the temperature in L1, and you put the ice cream sales in L2, and then you went to Stat, and you went over to Calculate, and you went down to option 8, it spits out everything else you need. So if you want to grab your graphing calculator and you want to put the data in and run through that process again, you'll go put in L1, put in L2, you go to Stat, you'll go to Calculate, and when you go down to that lin reg option that we used before, lin reg, and we did a plus bx, it spits out something that looks like this. Okay, it spits out at the top y equals a plus bx. Then it lists a and b below. That's the stuff that we need to plug in. So instead of y, because this is a model, I'm going to use y hat. Straight off of the calculator, the a value was negative 159.5. Yes, you can round if it is not pretty. Then the b value was a positive 30.1, and we follow that up with x. So I literally have to plug the a number in that slot and the b number in that slot, and I need to remember my y hat, and I need to remember my x. And so when it asks for the line of best fit, that's what it's wanting you to find. So let's try another example together. So we haven't seen this one before. This table shows the annual income and what percentage of households own their cars. So first we're going to create a scatter plot. We're going to go ahead and run through the instructions. So our low, it looks like, is 15,000, and it looks like our high is 100,000. Well, and of course that's your x and this is your y. I don't like thousands, and I probably am guessing you guys don't either. Here's a nice little easy thing you can do. You can forget about all of these extra zeros, and I can come over here, and when I label my x-axis income, instead of just dollar sign, I'm going to write this as thousands of dollars. Because then I know that all of those numbers are thousands, and I don't have to worry about all those extra zeros. So 100 minus 15 is 85. I'm going to divide by 9 boxes, and I get 9.4, which we're going to make approximately 10. It's a lot easier to count by tens. And so we look at percent ownership. I'm seeing a 55 for my low and a 95 for my high, so that gives me 40 when I subtract. Oh, I was wrong. I did not get the highest. It's not 95. It's 97. So I get 42 divided by 9. I get 4.6. So I'm going to count by approximately 5s. So my income, I'm counting by tens, and I'm going to go ahead and start it counting at 10 because I need to include 15. And I'm going to count all the way up to 100. And so then my percent ownership in percents, I am counting by 5s, but I don't need to start at 0. So I'm going to go ahead and just start at 55 because that's a nice multiple of 5, and I'm going to count by 5s. And notice I made my break because I didn't start at 0. All right, and so now I'm ready to graph my dots. So at 15, I'm going to go up to 60, so right in the middle there. At 30, I'm going to go up to 55. At 40, I'm going to go up to 75. At 50, I'm going to go up to 85. At 60, I'm going to go back down to 83. At 70, I'm going to jump up to 97. At 80, I'm going to go back down to 89. At 90, I'm going to be at 90. And at 100, I'm going to be at 95. So we see that they do kind of cluster to a straight line. And so the other thing, of course, that we need to find is the correlation. We need to calculate the correlation and the equation of the line of best fit. So pick up your graphing calculators, hit the stat button, edit, clear out your old data, type income into L1 and percent ownership into L2, then go over to stat, and then calc, and then option 8. And so the first thing we need is correlation, so that's our R guy. So your R value should be 0.876. Then we need to fill in our A and our B for our model. So since it's a model, it's Y hat equals. Your A should be 53.6, and your B should be positive 0.46x. And those are the two pieces of information that we need. So that is our equation that we can use for modeling. And so now that we have a couple of equations and we've practiced the calculator side of it, we need to talk about this making predictions part. So that's the next slide. There are two types of predictions. The first type of prediction is what's called interpolation. So this is a prediction made for an x value that falls within the range of the original data. Okay, that's a big important key factor here. The x value is within our range of data. For these types of predictions, you should feel confident making these predictions because the x value, that means, is close to the average because it's within our range of data. The other type of prediction is extrapolation. This is a prediction made for a for an x value outside of the range of the original data. These, we should not always trust the reliability of these, mainly because you don't know what happens outside of your graph. If it's too far outside of the graph, perhaps the graph actually starts bending back down or starts going back up or flattens out. So you don't know that, and so because of that, we don't know how reliable the answers are going to be. And so when you make predictions, it's going to ask you to make a prediction, and then it's going to ask about your confidence. And so if it's within our range of data, we would say we are confident. If it is not within our range of data, we would say we are not confident. So the first problem asks us to go back to example 1, that was the ice cream sales problem, and do a prediction for that one. So I'm going to reference back and rewrite down my equation. Our equation from the ice cream problem was y hat equals negative 159.5 plus 30.1x. And so it wants us to predict the sales for a temperature of 21 degrees. So x was our temperature column, so I'm going to put 21 in our x place. So it's going to look like y hat equals negative 159.5 plus 30.1 times 21. And so you can pick up your calculator and you can type that in exactly how you see it written. And I get a y hat of 472.5. point, and I'm going to use 2 decimals, 60, because this is money. And so how confident are we in this prediction? Well, our original range of data was 11.9 to 25.1. And 22 falls in that range. So we are confident because 21 degrees is in our range. So let's look at the other example. So now we're referring back to example 2's equation, and that equation was y hat equals 53.6 plus 0.46x. And so this time we want to predict the percent ownership for an income of 48,000. And if you remember, we knocked those zeros off when we put them in the calculator. So we're just putting 48 in the x spot. So I'm going to go y hat equals 53.6 plus 0.46 times 48. And type all of that in our calculator. And I get 75.7%. And so again, are we confident this time? 48,000, our range for the income problem was 15,000 to 100,000. So again, we are confident because 48,000 is in our range. And so as you can see, that's the end of the lesson. When you get to class, our homework for this chapter is a very large packet that we're going to do a little bit each day. So you'll get that packet in class and you'll work on just the first day's work.